Hey guys, so today's episode is going to be a little bit different, or at least it's going to start off a little bit different. We're going to start off in my house because we need to design this turbo manifold. I'm a mechanical engineer by trade, so I can use SolidWorks, Creo, Autodesk Inventor, etc. What we're going to do is use Fusion 360. It's a free version of design software. You can get it online, you can download it. Fusion 360 is easy, it's free, and it does exactly what I need to. So I'm going to show you guys what I've done already, which worked all right, but I'm going to do a third revision of the manifold and take you guys with it from mostly start to finish. I'm going to walk you guys through what's already been done and show you what we're going to do. Here you can see the first two manifolds I printed. This was the first one. My thought was that the turbo would sit square off the side of the engine, but it's the turbo's too big and it hits the shock tower. So while this is good and would work in theory on a smaller turbo, it does not work for the 7163. So my next revision, which a lot of you probably saw on Facebook or Instagram, is this angled manifold setup. So this plane is a 45-degree angle from this this right mounting surface here. So what it does is it tips the turbo up and away from the shock tower, and it actually brings it closer to the engine itself, which is really nice. What it'll end up doing, so I couldn't go 90 degrees, that was going to be my first, and mount the turbo essentially on top of, so if the flange had sat like this, the turbo would sit right on top. That's not an option because there's not a lot of hood space, and it's also a pain to mill out some sort of 90-degree flange. So this 45-degree did the trick. It fit perfectly. It actually fits so well on this guy that I could put the turbo on it and just let it sit there on its own, and it held it perfectly, which is awesome. So what we're gonna do to make this easier to machine is, for 34 bucks, is you can buy the proper BorgWarner EFR specific V-band flange, which is this, and it comes with the V-band clamp and everything. And I'm going to modify this, which is this model right here, and I'm going to essentially cut it right here. Well, we'll get rid of the loft, we'll cut it here, and then I'm gonna put just a circle there that you can see there's a tiny little step in here, and I'm going to do the male version of this so that when this gets machined, it'll have two flat circles, and then this will kind of lock into it, and I'll have James just weld the bead around here, because James welding time and the $34 that I spend on this flange that comes with the clamp that I needed to buy anyways is going to be much cheaper than a 5-axis operation to get a mill to come down and around. If I can just do essentially 2-plane operation where they're going to mill it this way, and then they're going to flip it upside down, and they're going to pocket out this inside portion here, which should get smaller with this back spacing. So I'm going to screen record this, and I'll voice over it as I'm going in certain spots, and I will show you guys the finished result. And then I'm going to do a 3D print time lapse so you can see the printer downstairs working, and then we'll mount it on the car and make sure that works. And hopefully by the end of this episode, I'm ordering essentially this from either a local vendor or somebody on 3D Hubs, and I'm going to get it milled out and machined and sent to me so that we can get the turbo fully mounted. So let's take you into the screen and we'll get cracking on it. So this is Fusion 360, and I'm just going to take you guys over like a quick crash course of how I did it. So in order to make the new manifold, I've got to delete the parts that I put on for the flange for the old manifold. So here I'm just playing around with layers and figuring out what I did where I stopped things. So fully constructed, I'm going to start deleting things that don't matter, like these fillets, hole cutouts, and things like that. I'm going to have to redo them later, and if I leave them in, it's just going to mess with everything. So what's important to me is that I keep the distance from the top of the existing flange to the top of the new flange that I'm going to put on, because this is the right piece. So you can see here as I rotate it around I'm going to take a measurement from the top of the flange to the inside where the flange stops. Takes me a minute to get the right orientation. And that distance, which is 6.4 millimeters, it's about 1/4 inch. I'm just writing that down, and I'm measuring the real flange that I showed you earlier, and I'm just going to compare the two side by side and see how much bigger is the new flange, and then I'm just going to take that extra distance, and when I recreate the lofts, I'll be pulling them back farther, so the offset of the plane will be different. That way when I weld the new one on, it'll be at the same overall height. Now that we've got all the measurements we need taken, we're going to start deleting the parts that we don't need, like these extruded faces. We're going to delete the loft here in a minute. I can't save the loft because it's based on 2 points, and I need to recreate it so that it's the right shape for the best flow and things like that. So you'll see here, I'm just going to delete the loft cut, and then I'm going to delete the loft extrude on the outside, and then I'm going to go ahead and start editing the plane like we had talked about earlier. So this plane is relative to this guy down here. I'm just going to hit edit, and I'm going to change this offset to the difference between the new flange and the old flange, so that I pull everything closer and the overall height is exactly the same. So we're just going to type in a new number here. It's going to pull that flange, I guess technically to the left, not that far, down to about here. And then we're going to sketch on that new surface. We're going to start laying out the new parts that we need. So this is the circle sketch. I'm going to edit it. The inner ring is going to be the smallest diameter of the flange that I'm going to weld on, so that there's a smooth kind of transition between the two. And the outer flange is just going to match the OD, or outer diameter, of the flange that I'm welding on, so that everything's a nice smooth transition and everything fits up real nice, and it gives James plenty of surface to weld to. There's no abrupt changes for airflow. It doesn't look chunky and weird from the outside. So I'm just going to make these changes real quick. So the next thing we're going to do is create a loft. So I have 2 features here. You can see the little oval that I have sketched out on the top surface here. I'm going to create a material section between this and the sketch that we did earlier. So you can see here I'm selecting the lower oval, and then I'm going to select the upper oval, and then it kind of extrapolates and builds its own little plane. And if you do direction instead of connected, you get the nice cool curved shape that's probably going to be really expensive to machine. But you get this face. So this is 90% of the work is done by just lofting these 2 surfaces. So it creates a solid, which is kind of a problem because I need air to go through here. So we're going to make another loft, and we're going to select the inner rings, and we're going to cut the material out, also setting it to directional. That way it gives you the most room for air to go through without being some sort of sharp corners or whatever. And we're going to hit OK. Make sure it's set to cut. And then you have what looks like 95% of an exhaust manifold for this engine. So you can see this looks great. Everything looks nice here. And the last step that we really have to do as far as functionality is to make the step that the new flange is going to kind of register onto to make sure everything's centered. So this diameter is just measured off of the existing piece, and I scale it down just by like 1/10 so that I'd have a slip fit. I'm going to finish the sketch. We're going to extrude that up to the same depth minus 1/10 that the female side is. And there you go. So the rest of the steps for this are just kind of beautifying the piece, except for one. We're going to put at some point, I'm just going to time lapse the rest of this, but we're going to put a 45-degree chamfer that's about an 1/8, either a 1/16 or an 1/8 of an inch around the welding portion, so that James has a valley to fill with weld. But the rest of this stuff, we're just going to add fillets. It makes it look nicer. In some cases, it makes it stronger. And we're going to cut relief holes so that we can get wrenches and sockets around the bolts as we install it to the manifold. It's often overlooked, but just because you can design it doesn't mean you can put it together. So we're going to add those reliefs, and then we'll cut over to the 3D printing software. Now that the design is done, minus that 45-degree flange, I actually went back and added that afterwards. We're going to export this as a .stl. It's the file that the slicing software can read. It's pretty common. Every slicing software for a 3D printer is the same. Most design softwares can export to this kind of file. And I'm just going to rename it so that I can find it. This is the weld version. That way I don't print the Rev 2. Yeah, so this is going to extrude, and then we're going to cut over to what's called Cura, which is Ultimaker Cura here. It's the program that comes with my Ender 5 3D printer, and it's super easy. I can't believe this stuff is free. You can download it even without the printer, so you can send files to buddies or whatever. So we're going to open up the model, which is this. So this is what we just drew in Fusion 360. And you can see there's some red spots. It's about a 9-hour print roughly. There's red spots on this, which means support material is required. It's not a big deal. It's just anything that's a 45-degree or more overhang, it needs to print material. That way the plastic doesn't kind of fall down as it prints. I could probably get away with taking it out because the printer settings are good enough, but it's peace of mind. I don't want to have to print this twice with this long of a print. I've got all my settings here in case you guys are trying to replicate this. This is for PLA. It's not a plastic you can really use in a heat environment, but this is just for test fits. It's super cheap, prints really easily. Yeah, so if you're trying to do this, feel free to copy my settings on an Ender 5, Ender 5 Pro, which is what I use, Ender 3. It's all the same. I've had incredible results with these settings, so we're going to go ahead, and it's sliced now, and the preview here will show us what it's going to look like on the print bed. It's kind of, there you go. So this is the full, this is what you'll see afterwards once it's all printed, and this actually shows you every individual layer. It shows you can run the print in here, and it will show you the extruder going around printing the entire buildup of this thing, so you can see, is there anything that's going to be wrong. As I zoom in, you can really see the layers here. Let's see how close I can get. You can see the layers, and you can see how the support material doesn't really touch. It leaves a little bit of a gap, and then somehow it helps it print better. It's super easy to remove. You just take a either flathead screwdriver or something, and you just pop it, and it comes right off. I do use a raft in this situation, which is that flat portion you see on the bottom. It prints this really wide platform. It helps with sticking the plastic down to the bed and all sorts of things. And the coolest part about preview here is you can watch it print. So that little yellow nozzle you're seeing is the extruder, and you can see it now does the support material first, and then it'll go to the outer layers first. I guess the inner and outer layers, but it'll do those first, and then it prints what you call infill. So I have this set to 20% infill. It leaves 80% air inside of the whatever you're printing, and this thing figures that out all on its own. You don't have to play with anything for that. It does the best layers and things like that. So you can see here it starts to like honeycomb the inside of the fixture. Super easy to use, and it's actually for 20% material. It's very strong. I took revision 2 and bolted the turbo up to it on the engine, and it's sitting there without any issues. So yeah, that's what we'll have when we're done. Let's go load this thing into Octoprint. It's a program I use that lets me print things from my computer instead of having to run an SD card down there, but it's just as easy as plugging an SD card into the printer. So we'll tab over to that real quick. So this is Octoprint. You can see I'm printing something right now. It's a Raspberry Pi based setup, and I can now load things in. So that file we just saved, it's It's going to be in here, turbo manifold angled weld, import. It pulls in that file that we just sliced in Cura, and it'll let me print it here. So what this is, it's a Raspberry Pi hooked up to my Wi-Fi and also hooked up to the printer. So as this file gets uploaded, I can start the print, or I can monitor it from my cell phone. I can look at it from this PC. I can check it really anywhere and start, stop, control the printer, things like that. And so you can see right now I'm printing. It's actually something to stop my drawers from sliding around for my silverware. Once this is done in 3.5 hours, I'll pop it off and I will load the new print and we'll get going on that. But let's go look at the printer now. So this is the printer. It's an Ender 5 Pro. You can get them for like $400 on Amazon. I've already used it pretty much constantly for like 3 weeks now. Comes with this display board and the metal frame. It's super easy to set up. Took me like an hour. I've clearly done some modifications like these lights. This is the webcam that I'm using to stream to Octoprint. It's running a Raspberry Pi hooked up to my Wi-Fi, and that runs the webcam and also lets me control the printer from anywhere on my Wi-Fi, which is really cool. You can see, so filament roll sits here, gets pulled into the stepper motor, and then into the extruder, which prints your material. Pretty simple concept, just heats it up to like 225 degrees, dumps it out, and as it cools, it holds its shape. So what I'm going to do is I'm going to printed the first two on here, and I've made some upgrades to the settings ever since, so it prints a little better now. I'm going to time lapse it on this webcam so you guys can see it just kind of build up, and I'll do a fast time lapse on it. It's an 8.5 hour print. I don't think you guys want to watch an 8.5 hour print. I know I don't. So we'll use this and then we'll test it, and by tomorrow I should have a manifold that I can hold in my hand and make sure it works with the turbo and everything, so that'll be pretty cool. So now that this is printing here, I'll take you downstairs. And you can see here, this is the raft layer that it's going to do. So it lays this down first. It does once, twice, 3 times, and then a fourth at another angle. And the fourth layer is like a mirror finish. And in the end, you'll get something like this that it pulls right off. Time lapse is on. Hopefully it works. If not, I'll show you guys the finished product. But it's just going to do its thing, and we're going to let it go and see how much of this spool we use. So here is the finished part. You can see the support material right here and inside here and on the edges there. That breaks right off pretty easily. I'm just going to pull it off the bed and show you guys. You just pry it up. I already started a little bit with one of these. And then this guy will break off with like a flathead screwdriver, which I have right here. And same with this little guy right there. Oh, just kidding. Comes off my finger now. So yeah, there's the test manifold. And we'll go upstairs and see if the V-band flange will sit right on there. And if it does, we'll test fit it on the car real quick with the turbo, make sure it's in a good spot. And then we will order this, which will be awesome, because then it's probably going to be a couple week lead time for this to show up. Surprise! It's me from the future. I'm actually editing this episode right now. The GoPro screwed this footage up, so I'm not sure what happened, but here's the piece we were looking at. Here's the V-band flange. You can see the little recessed lip. So the fitment is so good that it's perfect. I could not have asked for a better fit around here. On the inside, it's incredible, perfectly smooth. Yeah, great fit. So this is awesome. This blew me away entirely. The accuracy of the printer, and then just the overall fit. So now I know when I go to order this out of stainless that it's going to be perfect. So back to past tense me. So here you can see the manifold. This is revision 2, but it's the same exact thing. I just swapped this face out for the machine face. It's bolted up. I only put 2 bolts in for now, but the bottom bolts do in fact thread in, so there's no issue there. But for the test, we don't need it. So I'm gonna take the turbo and I'm gonna set it on here, and I need to kind of brace the front with a, this is a Expo marker, Expo board eraser, whiteboard eraser, whatever. So I need to brace the front just because it's front heavy. I don't want to put the flange clamp on here and like crack this whole thing. So I'm gonna set the camera up and I'll show you guys what that looks like. So there you have it. It is sitting on that flange. There's plenty of room for a water line to go down right there. Water return over here. Oil feed, we're gonna go this way, which is gonna be probably next episode. We're gonna work on this, even if the manifold isn't done. I'm gonna do exactly this, and I'm gonna start running those lines because I have all the parts sitting over there. So we'll get all that situated in the next episode, but this is the turbo, and you can see, I mean, this is like, I don't know, probably 4 inches, 5 inches. So we're gonna have to come down with a down pipe, and it's just gonna snake right down and hook up to the crossover tube that's gonna be right there. So the fitment, I really couldn't ask for a better situation. I could have moved it forward, but I don't think it buys me anything. I'll have plenty of space with the downpipe. My only concern is gonna be this guy. But as far as heat goes, I'm gonna be dropping it off at Swain Tech. The downpipe will be Swain Tech coated. It'll be heat wrapped, and I'm likely gonna put a little heat shield here or something like that. But fitment is excellent. I'm stoked. Can't tell me that this doesn't look awesome. So yeah, and we've got solutions now. I talked to some people. I'll give them a shout out in the next episode, but I've got solutions for the water feed and return, which is awesome. So I've got those halfway done. Hopefully I'll finish them up this week. Some special welded parts, but everything is going to be AN. 4 AN oil feed, 10 AN oil return, 6 AN water lines. For this episode, I know I was trying to get machining the exhaust manifold into this episode, but timelines and things like that, it's just not going to happen, and there's a good chance that I have to outsource it just based on cost. So if I can film it, it'll be another episode. If I can't, you'll see the finished product when it shows up. But for this episode, that is going to be a wrap. So huge thank you to you guys. You know, this has been a ride. It's been an awesome journey. I've never essentially built my own turbo kit before. We got some cool stuff coming, so make sure you smash that like button, leave a comment, let me know what you think of this 3D printed manifold. And if you're interested in a 3D printed manifold, send me on Instagram at Napp Motorsports or at KMiata. Send me a DM. I'm trying to do a group buy on it, maybe for like 5 or 6 people. It'll be around $600 a piece, shipped to you, fully welded up. You'll have something that bolts to the motor, and then it'll come with the clamp for the turbo side, and you can literally bolt a V-band, or you can literally bolt your EFR V-band anywhere from 6258 all the way to 9690 or whatever the huge size is. They should all bolt right up. So let me know if you want one, and I'll make it happen if I can. So thanks, and I'll see you guys next weekend. Make sure you smash that subscribe button down below.